Hi all. So today we'll discuss messaging queues, and as agreed, we'll talk in terms of what, when and why. So before starting with messaging queues, there is one prerequisite, that is sync versus async call. So let's see what exactly we meant by sync versus async calls. So in different contexts, sync and async means different things. But let's take an example. Uh, Whenever the caller is blocked on the response of any call, that particular call will be sync in nature, and whenever the caller is not blocked on the response, that particular call will be async in nature. Let's take an example of a bill fetch. So you enter your bill number and then you click on fetch. So unless or until the response of this bill fetch arrives, right, you are blocked. You see a spinner icon or a processing icon, right? So that means you are blocked on that particular call, and that particular call will be of type sync. Now let's take an example of a actual bill payment. So after you have made that payment, right? So the bill payment can take minutes or sometimes even hours, right? So that particular call is async in nature. Let's take another example, a cashback, right? Cashback arrives probably sometimes in hours, sometimes in days, right? So that particular call is also of type async. Now, let's move to our original topic of discussion for today, that is messaging queue. So in simpler terms, messaging queues provide async communication between two or more services. So messaging queue provides async communication between two or more services. Let's take an example. Let's suppose we have our web app, and then you have a microservice for the bill fetch, and then you have a microservice for cashback. So the interaction between the web app and the bill fetch will be sync, right? Because the user is waiting for the response of bill fetch to arrive. But the communication between the web app and the cashback can be async, right? Because user is not waiting for the cashback, right? Although the user is waiting, but not immediately. It's fine that the user will receive the cashback in couple of hours or even days, right? So these two communication between the web app and the cashback can happen asynchronously, right? Now let's jump to when part. When we use queues. So whenever there is a communication between two services that is async in nature, we use queues. Now, why exactly we use queue? So let's talk about some of the benefits that we get out of the queue. So for example, let's take there are two services, service A and service B. Let's suppose this is order service, okay, order service, and then this is a cashback service. Now the queues improves the performance. Let's see how. So let's suppose if for any of the order it will call the cashback service and wait for the response of the cashback service to come, right? And let's suppose the cashback service is slower than the order service, right? So obviously the order service will also become slower, right? Because this call will be waiting for the response from the cashback service, right? So this will make our order service slow. Now if instead of using a sync call, if we use a queue, then the order service does not need to depend upon the cashback service. It will directly put into this queue, and the cashback service will read from this queue whenever required, right, at its own pace. So the messaging queue improves the performance of a system. The second thing is decoupling. Obviously the messaging queues decouple these two systems, right? Now the cashback service does not need to know anything about the order service, and in the same way order service does not need to know anything about the cashback service altogether. The order service will directly put into the queue and the cashback service will read from this queue directly. So it provides the decoupling. Now scaling at granular level. What exactly mean by scaling at granular level? Let's suppose there is a sale event that is going on, right? So obviously the order service will be scaled. Cashback service will also be scaled, right? But let's suppose if this order volume is going to be only for, let's suppose, couple of minutes, because there is some sale event that is only for couple of minutes. Let's suppose the flash sale, right? So in that particular case, this order service needs to be scaled properly for that flash sale, and this cashback service does not need to be scaled, right? Because we know that this spike in volume is only going to sustain for a couple of minutes or couple of hours only, right? So by using queues, it provides the flexibility of scaling at the granular level. So not all the dependent services needs to be scaled. All the services can be scaled independently, right? Only the messaging queues that will be able to capable of, theoretically it will be capable of carrying infinite messages. This queue needs to be properly scaled. This order service needs to be properly scaled, but not the cashback service, right? So these were some of the benefits of using the queue: the performance, decoupling, scaling at the granular level, right? Now let's talk about the types of queue. So one simple queue is, let's suppose there are multiple producers, okay, and they are putting message into a queue which is consumed by a single type of consumer. Single type of consumer. So this will be more of a producer consumer. Now let's talk. There are, let's take another example where there are multiple types of consumer, right? So this is consumer group 1, this is consumer group 2, right? So this is a typical example of a newsfeed, right? Multiple users subscribe to a newsfeed, and whenever the producer puts any message into the feed, all the subscriber gets a notification about that particular message, right? Now, so there are multiple topics which the user has subscribed to, and based upon that it can take the decision. If we take an example from of a system, let's suppose this is a order queue, or maybe the order notification queue or the order queue, let's suppose. So there will be multiple events, right, in this queue. One will be created, one will be cancelled, one will be, let's suppose, modified, right? And there will be different types of consumer which will be interested in one or more different types of messages. Let's suppose this fulfillment, which will be required to have information about all types of order creation, modification, deletion, right? Now there is a let's suppose cashback will also be interested in, let's suppose, order creation, deletion, every event. But there will be some services which are interested only in, let's suppose, order creation. So let's suppose there is a service which counts how many order got created or how many order got placed. So that particular service will only be interested in the order creation, right? So with this is more of a pub sub model. So where there is a one or more publisher which publishes the message into one or more topics, and there are multiple groups or multiple types of consumers which consumes the messages from one or different topics. Let's take some of the examples of the messaging queues. So one of the most prominent example of a messaging queue is Kafka. There are some other example. RabbitMQ. And if you are familiar with AWS World, then you must have heard about the SQS, Simple Queue Service, right? Now, let's talk about one more concept of message delivery. Message delivery. So there are three concepts: exactly once, at most once, and the third one is at least once. So as the name suggests, exactly once ensures that the message will get delivered exactly one time. At most once means message will get delivered at most one time. Some message can get lost as well. And the third type is at least once. So the message will get delivered at least once. It may happen that the message will get delivered twice because of some problem at the, let's suppose, in processing or getting the response from the communication between the producer and the queue. And based upon your use case, you can select any one of the types where, let's suppose, the delivery is so critical, probably you will rely on at least once delivery. And whenever you are so critical on that it should be processed only one time, so exactly once can be implemented. There's another type of queue. There are two different types of queue based upon the delivery. So that's the FIFO or a standard. So FIFO means first in, first out. So whenever the message will arrive, the message will get delivered into the same order. And in the standard, the ordering is not guaranteed. So by default, in normally in any queue, the delivery of the message is not guaranteed in order. Mostly it is in order, but it is not guaranteed. But there are some services which require the messages to be delivered guaranteed in order. Then you can consider implementing a FIFO queue or using the FIFO queue from the SQS or adding some configuration in the Kafka to make it a FIFO queue, make it behave like a FIFO queue. For example, let's suppose the flash sale, right? So in flash sale, the user processing should happen in the order they clicked, right? So probably FIFO is not used there, but let's suppose, for example, if a queue was used there, then it should be of type FIFO. And for all normal processing, you can use the standard queue. Let's suppose for the cashback, right? It does not matter if me and you have placed the recharge order at the same time. It does not matter my cashback will get processed first or yours, right? It's fine if I'll get my cashback, let's suppose, after 1 hour or after 2 hours as well, right? So normally a standard queue is used, but whenever there are use cases where the ordering is important, then we need to ensure the FIFO. We need to use the FIFO queue. Got it? Now, hmm, so now let's see what exactly is the use of queue in the system design interview. Now I'll focus specifically about the system design interview. So queue is one of the most used concept, and queue is one of the most basic concept of any system design. So in system design interviews, no matter what the design says, there will be one or the other opportunity of using the queue. Always look out for the opportunity of using queue. So whenever you can find any of the call that is async in nature, feel free, go ahead, use the queue there. And then if you see some use cases for the FIFO or the exactly ones, talk about those concepts. It gives the interviewer the perception that you know about the queue, you know about the sync and the async nature, and you know about the implementation of the queue as well. So whenever the use case arrives, always use the queues one or in the other way. And always look for the opportunity of using queue in the system design interview, because that's the one of the most fundamental and basic concepts. I'll stop here. Feel free to ask any question. Post your question in the Google Classroom or in the Telegram channel. I'll give the link in the description. Thank you.